Hi everyone, my name is Mehedi Hasan Ovi. My student ID is 20032550. Today I'll be talking about something important in computer security, which is Secure Boot and Trusted Platform Module or TPM. Let's start at my presentation with the overview. Here is a quick outline of what I will cover in this presentation. First of all, I'll start with a short introduction to firmware and why the old BIOS had secure problem. Then I will explain how UEFI and secure boot fix those issues. After that, I will talk about the role of TPM and show some real world uses and challenges as well. And finally, I will sum up the whole presentations. So let's start at my presentation with a quick introductions. When you turn on your computer, the first thing is that the firmware, either BIOS or UEFI. It checks the hardware, makes sure everything working, and load the bootloader to start the operating system. The issues with traditional BIOS is that it didn't have any real world, it didn't have any real security. Hacker could install rootkit or bootkit before OS even started, which is very hard to detect. So the solution is a modern system uses UEFI with something called secure boot, which only allows trusted software to load. Then I will try to uh, show some difference between UEFI and BIOSes. So what's the main difference between UEFI and BIOS? Well, BIOS is old, simple, and not very secure. On the other hand, UEFI is modern. It supports faster booting, larger storage, and main point for us is secure features like software boot. Basically, UEFI make the startup process safer or more reliable. And here are some more differences between here are some more differences that I have added here, like 16-bit for BIOS and 32 to 64-bit for UEFI, and BIOS has stage-only interfaces. On the other hand, graphical or mouse support function has UEFI like this, and BIOS no cryptographic checker has no cryptographic checker. Our UEFI has secure boot, digital signature. Uh, Now I will explain how secure boots really work. Here is a diagram I have added to represent the visualize this work. And first of all, secure boots work by creating what is called chain. When the computer is started, it checks each piece of software against digital signature. And here are some keys that is uses like PK, K key, and DV and DVX. And what trusted and what's not, and these keys are decided. If something doesn't match, the system block it before the operating system even load. The main malware can't sneak it at startup, that's why. And now I will explain the role of TPM. Like now TPM or trusted or the now TPM is referred to Trusted Platform Module is a small hardware chip built into the computer. Think of it as a secure guard that store keys safely and keeps track of system state. It works together with secure boot tools like BitLocker to make sure the system has not been tampered with, and if something suspicious is detected, TPM can stop access. So it add another layer of protection, but this time it hardware. And now I'll explain some real world uses and challenges as well. In real life, secure boot and TPM are used almost everywhere. Like Windows uses secure boot to verify component, TPM to check integrity, and BitLocker to encrypt drivers. And Linux support in too, though it's bit trickier with dual boots startup. And in big company, these features help protect sensitive data and meet secure requirement. But it has some challenges as well. For example, dual booting Windows and Linux can cause issues. Firmware update something break the chain of trust, and BitLocker or auto unlock inconvenient but reduce security. And in large organization magazine, managing all the covered key can be real headache. So last of all, I'll try to conclude the whole presentations. To sum up, we can say that Secure Boot and TPM work together as a layered defense system. Secure Boot makes sure only trusted software run at startup, and TPM at hardware-based protection. They are widely used and very effective, but they are not perfect. Things like dual boot issues, spammer update, and key management are still changes. And this is the limitations. And thank you for your listening.